So MPLS is a label switching protocol. It still depends on the routing protocol for routes. So it is a 32-bit value that is getting added to the Ceph table. A label will be added, and 32-bit value is added to the 2.5 of voice, right? The labels are generated and distributed using LDP. All these things we saw. In today's class, what we are going to speak is we are going to learn about VRF. VRF stands for Virtual Routing and Forwarding. What is this? This is a control plane that you can create on a router. What happened to the control plane which is there by default? See, every router has got a control plane. What is control plane? The plane that has got the path information using which the traffic can be controlled. That is what control plane is. If you take router, routing table is a control plane example. If you take a switch, MAC table is a control plane. MAC table and spanning tree is a control plane. So what I'm coming to say is VRF allows you to create many control planes. Why do I need many control planes? When I have already a routing table, what is the reason? Why do we need many control planes? What is the purpose of having many control planes? Let's discuss that. You see, I got a router, and let me call it as provider edge 1. I got another router, provider edge 2. Why do we call this as provider edge? Because it is connecting to multiple customers. Let's say I have a customer called Orange. I have a customer called Orange. Orange customer. And I have another customer called MTN. From Orange, there are some routes coming, and which I want to give it to remote Orange. There is remote Orange here. I'll put RO, remote Orange. So the routes that are advertised from Orange should be given to remote Orange. Likewise, the route that are advertised from MTN needs to be given to remote MTN, for which we need a VPN. We will be forming VPN using BGP, which I told you in the previous class. But when it goes in a VPN, see, you may have many routers in between. You'll be forming a VPN between these two E routers. So the routes that are coming from Orange will go through this VPN, and it has to go here. Likewise, the routes that are coming from MTN should go through the same VPN and go to MTN, for which there is need for separation of MTN and Orange. Router should know that this Orange route This is MTN route. Routers need to know, the PE router need to know these routes belong to Orange and these routes are from MTN, for which you need to learn it in a separate control plane. You need to create a VRF, which is called a routing table or a control plane for Orange, another VRF for MTN, so that the routes of Orange and MTN will not get mixed. Also, the routes of the ISP, the routes of the service provider, the network routes of the service provider, the network routes of the service provider should be maintained. It cannot get mixed with the customer route. Should be maintained separate. So you got another routing table, which we called as global routing table. That's our usual routing table. Now, when you create VRF for Orange, VRF for Blue, what you're creating is you create a Orange routing table, Blue routing table. So there's going to be a separate control plane for each customer. That's what VRF is. VRF, virtual routing and forwarding. You're going to create a routing table, which is nothing but a forwarding table, because based on the routing table only packets are forwarded, and because it's a layer 3 we call it as R, routing forwarding, virtual routing and forwarding. It's not switching forwarding, it is routing forwarding, virtual routing and forwarding. So Orange advertised routes will never go to MTN. It will go only to remote Orange. Likewise, MTN advertised routes will not get mixed with the provider's network. It will be handled separately. As a result, if Orange and MTN and the service provider have got same network in their organization, let's say Orange has got 10 network, MTN has got 10 network, inside service provider also got 10 network, no problem. They won't conflict because they're all going to be in a separate control plane. So VRF is creating multiple control planes. VRF is creating multiple control planes so that you can have a separate control plane for each customer. I would like to show you this in a demo. So we will create VRF in router 3 and router 7 so that the routes coming from BGP 10 will not get mixed with the provider's network. In fact, if you go to these 4, 5 and 6 router, they will not have any route information that are coming from BGP 10. In router 3 and router 7, you will have in a separate VRF routing table, not in the global default routing table. Global default routing table is also called as default VRF. Default VRF. We don't have any VRF now. If you trace route from router 1 in the left to router 2's loopback in the right, you will be seeing every hop, and you will be seeing the routes use the same common control plane, which is both for ISP and the customer. Let me show you that quickly on R3 routing table. Wait for some time, it's booting. We got neighbor between R1 and R3. Show IP route. If you see here, the customer, R1 is considered as a customer. Show IP BGP. Summary. Okay, so for no prefix len key sometime it'll come. R1 is going to advertise you a network 11111. So for no prefix learned, there will be one prefix. Yeah, two prefixes learned. Show IP route 1.1.1.1. You see, you got a route in the same routing table where the provider network is also kept. You see, show IP route. You see customer's route, and this 333.444.555. Whose route it is? It's provider's route. We see all in one routing table, which is not good. To avoid it, what we do is we create a VRF. This is the command IP VRF. I'm going to give a name as orange. Then for routing table of this orange, there is need for an ID. Focus, this is important. There is need for an ID to identify the routing table of orange. For that, the command is RT. And it is a 32:32 bit ID. In total, it is 64-bit ID. So I'm saying 32-bit as 1, another 32-bit as another 1. One colon 1. Next is what? I need to put an interface, the customer's interface inside this VRF, inside this newly created routing table. As of now, you created a routing table, but there is no interface to this routing table. Why? All the interfaces are there with the default routing table. So what I do is I go under interface G0/0 and say IPVRF forwarding orange. Meaning I'm saying you belong to this interface, you, hey, you, G00, you belong to the routing table orange. When I say this, it will remove the IP addresses if it is already present. Yes, we already have IP address 10.13.0.3, which got removed, so I'm putting it back. All right, now let us go and verify this. Show IP route VRF orange. I want to see the routing table of orange. You see, you can see the routing table of orange with one interface. If you don't put orange you will not see G00 in the global routing table. Why? Because global routing table don't have that interface. So you will not find G00 anywhere in this routing table, global routing table. Because G00 has taken from the global routing table and it is given to the VRF called orange. Right. Next. Show IP VRF. You can see here the VRF that we created and the route distinguisher to identify the VRF, and then the interface membership. Now, if you want to learn the routes from the customer, you need to run BGP in a different way. Router BGP. Where's the BGP currently running here? Any idea? Maybe 100, let's see. No, it says 20. No problem. I'm doing 20. And now, router BGP 20, you need to go under address family because your neighbor is not in the global routing table. He is in the IPv4 VRF called orange. So using this orange ORA need to give exactly the same name. And then I need to say my neighbor is 10.13.0.1, remote AS is 10. Now you will see the neighbor coming up. See, we got a neighbor, but this time it is via a VPN VRF called orange. It's not through a common routing table, it is through a orange routing table. I told you VRF is a routing table. Now let us check. Show IP route VRF orange. You will see now the routes given by BGP. You see. Earlier this route used to be there in the global routing table, but now it is in the VRF orange routing table. Did you understand VRF? Do you have any question on VRF? Please ask. No questions? Okay, so for you, I'm going to do one more similar configuration on R7. So I'm owning this router 2 now. And then I'll go to router 7. I'll remove the interface from the default routing table and I'll put it into VRF. So here also I'm going to create IP. So yeah, IPVRF. That said, I gave orange. This side you can give Apple also, no problem. Even though it is the same customer, the name doesn't matter. But I just want to give orange. What I want to say is you can have different name for the same customer. That's okay. And route distinguisher there I gave 1:1. Here you can give same 1:1 or different number. It is okay. I'm going to give 11:11. I'm just trying to tell you that these things need not to match with the remote PE for the customer. For the same customer, you can have different name, different route distinguisher, no problem. Next, I'll go under interface G0/0 and say IPVRF forwarding. IPVRF forwarding. What does this mean? I'm telling G00 you don't belong to global routing table, rather you belong to a special routing table called orange. And then it will remove the IP address, so I put the IP address back 10.27.0.7. All right. The next thing is we need to run BGP. Router BGP 20. You need to go under address family IPv4 VRF to form neighbor. Neighbor is 10.27.0.2. Remote AS is 10. And you will see neighbor coming up. If in case neighbor is not coming up, what you will do? You will try to ping now. But if you ping simply 10.24.27.0.2, it won't ping. You need to ping with the VRF orange. So whenever you're pinging someone who belong to VRF, see, in order to belong to VRF orange, so if you ping like this 10.27.0.2, it will not ping. Why? Now it is trying to use the global routing table to ping this guy. But we don't have this guy in the global routing table. We have him in the VRF routing table. Before that, I want to check whether R2 is ready because we just started. I don't think so. It is ready. Let's wait for some time. And then I'll again ping and show you. The neighbor itself has come up, but the ping is not happening, you see. The ping is not happening. The ping percentage is 0. But when I ping using VRF orange, now the ping will go. See? So we need to keep in mind that when you create a VRF, you're creating a control plane. And the routes that you want to reach, the destination that you want to reach for those networks that is there in this VRF table need to be sourced from that VRF table. If you simply ping without sourcing, like you saw, it won't ping. So if you're pinging a customer orange, you need to use the IPVRF orange, which is the VRF name given to orange customer. Right, today I just gave you an introduction to VRF. This is the beginning of L3 VPN. In our next class, we are going to see how to form a VPN and bridge between this VRF and the VPN so that left-hand side orange can ping the right-hand side orange. As of now, the ping will not happen. I'll save this here, then we'll continue in our next class. Anyone has got any question? See you later. Bye-bye.
Awesome. Thank you.
Bye-bye.